Transmission of solar energy using fiber optics. Abstract. India is the world's third largest producer and consumer of electricity. India produces 37% of total electricity from renewable sources of energy and the rest from non-renewable sources of energy. India is about to leapfrog fossil fuels to generate all the growth in their electricity supply from renewables. The solar light can be harvested, concentrated, amplified, and distributed indoors by fiber optics to replace most of the electrical lighting. The whole system automatically tracks the intensified sun rays with help of an electrical sensor and microprocessor. According to the intensity of sunlight, the parabolic reflector will maintain its position to transfer the maximum sunlight. The system is equipped with biaxial tracking movements. The parabolic reflector or dish will act as a sunlight concentrator which will reflect sunlight to the mirror, i.e. focus of the reflector. Other than energy and capital saving, this system is also good for the psychological health of the citizen. To carry out fiber optics daylighting system, many aspects are needed to consider, like the climatic condition of the Earth, rotation of the Earth about its own axis. This paper is going to highlight the fiber optics daylighting system along with the automatic tracking system. Keywords: daylighting, optical fibers, solar collection, solar concentrator, solar tracking. Introduction: the consumption of electrical energy is increasing day by day due to rapid industrialization and urbanization. Therefore, the consumption of fossil fuels and other non-renewable sources of energy are also proliferating. Daylighting system can partially help in reducing the consumption of non-renewable sources of energy. Moreover, conventional can-scent and fluorescent lamps have been indicated in aggravating depression, aggression, eye strain, reduced muscle strength, obesity, and diabetes. Therefore, the daylighting system must be installed in indoors and libraries to reduce the psychological impact. After a study, we've found that at least 4 fiber optic daylighting systems already exist. It's Himawari, Parents SP3, HSL, Hybrid Solar Lightning, and Solux. The 3 systems utilize Fresnel lenses to concentrate the light and one utilizes a parabolic mirror. To maximize their potential, all these systems employ precise manual solar tracking devices. The purpose of this paper is to improve the working of the daylighting system and fabricate an automatic tracking system. In our proposed system, we are going to use the parabolic reflector, in which a concave mirror will be attached. Sun rays will fall on the surface of the mirror and will be redirected to focus off the mirror. A coupler is attached to the focus, whose work is to inline the sunlight and optical fibers. 3 stands are attached in a parabolic mirror dish to support the focus and coupler. Many types of optical fibers are available that can be used, but the 4-core and 6-core optical fibers are recommended to maintain cost effectiveness. To maintain the efficiency of the system, a light-dependent resistor, LDR, is used, which works on the principle of resistance. Along with the LDR sensor, a microprocessor is also attached, which will give the command to rotate the parabolic mirror dish towards the higher intensity sunlight with the help of a motor. Parabolic reflector. The parabolic reflector works on the phenomenon of the reflection in spherical mirror, which is based on the principle of optics. In the parabolic dish, a concave mirror is attached to its surface. And according to the law of reflection, whenever light strikes on the surface of the concave mirror parallel to the principal axis, it will reflect to the focus of mirror as shown in figure 1. The same reflected light is projected into optical fibers through a coupler. The dish is generally connected to the stand, which acts as a base wherever we mount it. The stand is connected to the servo motor, which helps us in rotating the parabolic dish. Optical fibers work on the phenomenon of total internal reflection, shown in figure 2, which occurs at the interface of the core and the cladding, provided that the angle of the incident light inside the core is greater than the angle called the critical angle. Therefore, the incident light will get reflected into the core and propagate along with the fiber. If the light strikes the interface at an angle greater than the critical angle, it will not pass through the other medium. Fibers generally consist of 1 core, 1 cladding, and a protective coating. It is evident from figure 3 that optical fibers consist of 4 parts, i.e. glass core, glass cladding, plastic buffer, and the outer jacket. A cylindrical shaped core section is made up of dielectric material having a definite refractive index. The core section is surrounded by the cladding section, which is made of glass or plastic with a lower refractive index than the core section. The fundamental role of cladding in optical fiber is to reduce the loss of light from surrounding air. The cladding section is surrounded by an additional elastic layer as buffer made of plastic, which protects the optical fiber from physical damage and scattering losses caused by the micro bending. The last layer is the jacket layer, which is used to recognize the type of fiber. Most fibers are made of quartz glass because of their purity. Types of optical fiber. To understand the key role of the optical fiber in daylighting system, we first need to study about the characteristics of the optical fibers based on the classification, then only we use the appropriate optical fiber in the lighting system. Basically, the optical fibers are classified on the basis of mode. There are two types of optical fibers, i.e. single mode, and another is multi-mode. The multi-mode optical fiber is further classified into step index mode and graded index mode, shown in figure 4. Single mode, it is a single strand of glass fibers that allows only one beam of the light signal to propagate. The core diameter of single mode optical fiber is of 8 micron. It is expensive in cost and is generally used for reducing dispersion. Multi-mode fiber is a type of optical fiber designed to carry multiple light rays or modes simultaneously, each at a marginally different reflection angle inside the optical fiber core. Multi-mode cable consists of glass fibers with a common diameter in the range of 50 to 100 microns for the light-carrying element. Fig. 4 Types of optical fibers. Tracking system. In our proposed system we have attempted to make the system automatic like a fire and forget system. To carry out the experiment we have used an LDR sensor and Arduino board, which is a combination of several microprocessors. Further information regarding the Arduino board and LDR sensor are given below in the paper. But first, we need to understand how these two components are going to help us out. We are going to attach an LDR sensor in a parabolic mirror dish to identify the higher intensified sunlight. 8 Whe, and the value of resistance increases, the intensity of light increases, and vice versa. The value of resistance is notified by the Arduino board and it gives the command to servo motor to rotate the dish, let's say, by 20 degrees. As we all know, Earth rotates 360 degrees around the Sun, resulting in day and night. So with the help of that principle, we can rotate our device automatically. So, now command has been sent to the motor and the motor is rotating the dish according to the Arduino board. And of course, we are going to need a system that gives power to these components. So, to resolve this we have used the small battery which will run all these components. A graph has been shown, figure 5, between resistance and light intensity to show the working of the LDR sensor. Arduino board and LDR sensor. Arduino is an open-source electronics platform based on easy-to-use hardware and software. Arduino boards are able to read inputs light on a sensor, and turn it into an output, activating a motor, turning on LED, etc. Arduino board designs use a variety of microprocessors and controllers. The boards are equipped with sets of digital and analog input/output, I/O, pins that may be interfaced to various expansion boards or breadboards, shields, and other circuits. The boards feature serial communications interfaces, including Universal Serial Bus, USB, on some models, which are also used for loading programs from personal computers. The microcontrollers can be programmed using C and C++ programming languages. In addition to using traditional compiler tool chains, the Arduino project provides an integrated development environment, IDE, based on the processing language project. A light-dependent resistor, LDR, is also called a photoresistor or a cadmium sulfide, CDs, cell. It is also called a photoconductor. It is basically a photocell that works on the principle of photoconductivity. The passive component is basically a resistor whose resistance value decreases when the intensity of light decreases. Light distribution system. As the final component in the daylighting system, distribution of light plays an important role to get an efficient result. Its main objective is to provide uniform lighting across a room without the effect of glare. It requires extraction and emission of light. The extractors can be at the end of the fibers, at multiple points, or in a continuous manner. The main function of emitter is to distribute and spread the light uniformly. There are two main types of extractors that work on the principle of total internal reflection: are light pipes and optical fibers. As we have used optical fibers, so we are going to discuss about optical fibers as an extracting device. Non-concentrating systems are more likely to provide a uniformly distributed luminance. Meanwhile, concentrating systems require a proper deconcentrating process to achieve a similar result, otherwise, a narrow light beam will be obtained, resulting in separate light batches using the average distance to height ratio. To resolve it, we can emit daylight in a glass tube or glass bulb where the distribution can be carried out. To improve the efficiency of daylight, we can use inert gases like argon, neon, etc., which will help us to elevate the luminance of daylighting system. Conclusion: the best way to predict the future is to design it. Energy conservation has always been an issue for India and other parts of the world. Efficient usage of energy has become the biggest issue nowadays. Non-renewable sources of energy are ending day by day. Fossil fuels and other sources are consumed at a very high rate. To resolve this problem we have to shift ourselves towards renewable sources of energy like solar energy. Daylighting system is the one of significant applications of solar energy. Daylighting system is the best way of using the sunlight instead of converting it into an electric light. While executing this idea we had to deal with the light intensity problem and movement of the Earth with respect to the Sun. Now to resolve this issue we applied some electrical and mechanical equipment like microprocessors and servo motors to track the higher intensified sunlight. Distributing a light through a narrow beam of fibers can be a tricky thing, so to get enough light inside the room proper distributor has been used like glass tubes and glass bulb with inert gases. Acknowledgement. I would like to take this opportunity to express my gratitude and regard to my project guide, Assistant Professor Manoj Raut, for his exemplary guidance, valuable feedback, and constant encouragement throughout the duration of the research work. And under his guidance was an extremely knowledgeable experience for me. There were many ups and downs during the research, but he was always there to support me and motivate me. I would also like to thank my institution, my professors, and the fellow classmates for supporting me and encouraging me, without which this research would have been incomplete.